Welcome friends, today we will solve a question on HCF LCM. HCF LCM questions are very common and these questions come in the CSAT exam, and I am solving few of the questions of the previous year CSAT exam. So let's start with the first question. A person X wants to distribute some pens among 6 children A, B, C, D, E, F. Suppose A gets twice the number of pens received by B. So if A is equal to 2B, 3 times that of C, so it is equal to 3C, 4 times of D, 4D, 5 times of E, that is 5E, and 6 times of F equal to 6F. So what I can see here is that these are the numbers multiples where A and the relation of others are shown. So to identify the value of how many A has, the best way is to find a LCM of this. So the numbers available are 2, 3, 4, 5 and 6. So we will write them in a more factorized form. So 2 will remain as 2, 3 will remain as 3, 4 can be written as 2 square, 5 will remain as 5 and 6 can be written as 2 into 3. So what we see is the least common multiple among all of this comes out to be 2 square into 3 into 5. So that is equal to what? 4 into 3 12 into 5 60. So that is the 60 is the LCM for these values. So if A is 60, then B becomes half of it, that is 30, C becomes 1/3 of it, that is 20, D becomes 1/4 of it, that is 15, E becomes 1/5 of it, that is 12, and F becomes 1/6 of it, that is 10. Now if we add these numbers, we will get the total number of pens that he needs to have. What is the minimum number of pens X should buy so that the number of pens each one gets is a even number? Now each one should get even number. Here we can see only one odd number. So to get it to even, we have to multiply it by 2. So A then will become 120, B will become 60, C will become 40, D will become 30, E will become 24 and F will become 10. So when we add these numbers, we get the final result. 120 plus 60 is 180, plus 40 is 220, plus 30 is 250, plus 24 is 274, plus 10. Actually 10 has to be written as 20 because this is to be also multiplied. So 274 plus 20 is 294. So the final answer is 294, that is the option C. Moving on to the next question, it says what is the smallest number greater than 1000 that when divided by any of the numbers leaves a remainder of 3. So in each case the remainder that is left is 3. So if we find the LCM of these numbers and add 3 to it, then we will get the actual number we are looking for. So again finding the LCM for 6, 9, 12, 15 and 18. So I will write them in the factorized form. 6 can be written as 2 into 3, 9 can be written as 3 square, 12 can be written as 3 into 2 square, 15 can be written as 3 into 5 and 18 can be written as 2 into 3 square. So what is the largest power of 2 available? 2 square. What is the largest power of 3? That is 3 square. And the largest power of 5? 5 only, that is 1. So we get 2 square into 3 square into 5, that is 4 into 9 into 5, that is 180. So now we get the number 180. Now what is the smallest? So 180 is the least common multiple. So the number we have to find out has to be a multiple of this. So what is the largest, smallest 4 digit number that we are looking for? 180 into 5 will make us to 900, and if we add another 180 to it, then it will make it to 1080, and we have to have a remainder which is of 3, so it should be 1083. The answer should be 1083. To know more how we have done this LCM and to understand what is LCM, the factorized form, please go to the video above. The link is being visible on the left side of the this video. You can go and see how the factorization is done, how LCM is calculated. Now we will move to the next question. Consider the following statement in respect of two natural numbers p and q such that p is a prime number and q is a composite number. So what are prime numbers and what are composite numbers? To know more about this, there is a video, the link is on the left side of the screen, you can see that, and then you can come back to this video. And q is a composite. So in a brief, I will tell, a prime number is a one which is divisible by 1 and its own self. So for example 5 is divisible by 1 and its own self, and composite is the number which is divisible by 1 and itself and any other number like 6. So 6 has factors as 1, 2, 3 and 6 itself. So 6 is a composite number, whereas 5 is a prime number. So it says the following statement, p into q can be an odd number. So p, which is a prime number, yes 5, and q, which is a composite number, in this case 6, so it will become even. But is there any composite number which is an odd number itself? Yes, 9 is one such. So 5 into 9 can be an odd number. So yes, 1 can be true. Q by p can be a prime number. So can we have something like q, which is a composite number divided by a prime number, becomes a prime number? Yes, it can. So if suppose 6 is there and we divide this 6 by 3, we get 2, which is a prime number. So this can also be true. Can p plus q be a prime number? Yes. 5 is one prime number. If we add another prime number 2 to it, we get 7, which is also a prime number. So this can also be true. So all these three statements are true. To understand more on prime numbers and composite numbers, factorization, LCM, please see the video. The link is available in the description and on the left corner of the screen. Moving to the next question, it says if 15 into so on is equal to 3 the power m into n. So where m and n are positive integers, what is the maximum value of m? So we have to find the maximum power of 3 in this. So how we can find the maximum power? So we will write down these numbers and we will see what are the powers which are there. So as we all know, 15 is there, 14 will not have any power, 15 will be written as 3 into 5, 14 is not a multiple of 3, 13 is not a multiple, 12 is there, then 3 into 4, then 11 is not, 10 is not, 9 is, which can be written as 3 square, 8 is not there, 7 is not there, 6 can be written as 3 into 2, 4 is not there, 3 itself is there, 5 is also there, which is not a multiple, and then 3 only. So what we see, that's all. So 1, 2 and 2, these 4, 5 and 6. So the maximum value m can take in this case is 6. That is the option B. Now consider the following statement in respect of a rectangular sheet of length 20 centimeter. So the length is somewhere like 20 centimeter and the breadth is 8 centimeter. Okay, so this is a rectangular sheet we have got. Is it possible to cut the sheet in exactly 4 square sheets? Now see, if the area we calculate, the area of a rectangle is L into B, length into breadth, that is equal to 20 into 8 is equal to 160. So if I divide it into 4 equal squares, the area of each square should be 40. But then that is not possible because it needs to have a square, has to be, area is to be a square is equal to 40, and 40 is not a perfect square. So first statement is not possible. Let's look at the second statement. Is it possible? It is possible to cut the sheet into 10 triangular sheets of equal area. Yes, this I think can be done. Why? Because a triangle, one this triangle and the other triangle, two triangles A and B can make a rectangle. So what if we have this 20 divided into 5 parts, like of each 4 size, 2, 3 and this. So 5, and then each one can be divided into 2. So this can be 1, 2, similarly 3, 4, then this one 5, 6, 7, 8 and 9, 10. So there can be cut into 10 triangular sheets of equal area, which each area having half into 4 into 8, that is equal to what? 16, and 16 into 10 comes out to be 160. That was the area of the actual rectangular sheet. So only 2 is the possible correct answer. So all the questions discussed above were the questions of CSAT 2023. These questions were based on factorization, LCM, HCF, prime numbers, and these could have been easily solved if someone was aware of how to do the LCM, HCF and factorization. So for more videos, please visit this channel, and for any questions, please mention your questions in the comment section. I will be happy to answer them. Thank you.